All right, so I'm going to begin by going through sine and cosine graphs. So starting with the sine graph, what you are looking to do here is you're looking to rewrite a unit circle coordinates onto an xy axis of a coordinate plane. So the critical points that you're looking at here are going to be at 0 radians, and I'm talking in terms of radians here. So 0 radians has the point 1, 0. Pi over 2 radians has the point 0, 1. The pi radians has the order pair -1, 0, and 3 pi over 2 radians has the point 0, -1. And then we return back to 2 pi where we have 1, 0 again. So if we were to plot here the x and or the sine values for these, the sine values here are your y's at each of those angle measures. So we're going to take the angle as our x coordinate and the sine as our y coordinate, and we're going to plot those on this plane. So we'll talk more about amplitude and different things, but the highest point and lowest point of your sine and cosine graph and just the parent function is +1 for the maximum and -1 for the minimum. Okay, we can see that right here, right? Here's the highest y value, here's the lowest y value. And so when we plot these, we're going to use these angle measures of 0. We'll go all the way to 2 pi. We cut that in half for pi, and then cut each of these in half as well. So we have pi over 2, and we have 3 pi over 2. So those are our 5 critical points on the parent function of a sine graph. And so when we plot these points, we get at 0 radians, there's a sine of 0. At pi over 2 radians, there's a sine of 1, so we'll plot that here. At pi radians, there's a sine of 0, so it comes back and crosses that axis again. At 3 pi over 2, there's a sine of -1, so it drops down to this minimum. And then back to 2 pi, it's at 0 again. So this right here represents the basic form of the sine graph. And the sine graph is called sinusoidal because it's going to have this wave-like pattern as it continues oscillating back and forth between the -1 and the 1. Okay, but this portion right here is called one period of this graph. Okay, we'll talk more about what that represents, but this is just one time through this unit circle sketched onto that graph. Okay, so when we are looking at the period, again, the period is the amount of time or it takes for one complete rotation through or one phase of this or cycle of this function. And the period can be found using this equation right here, much like we've done in other functions. But here you can take the period is 2 pi over the absolute value of b, where b is the multiplier in front of the x value inside your function. And now b itself, if you're looking for this value of b, is going to represent the number of cycles for this graph that fall between an interval of 2 pi. Okay, and so we'll talk more about that too when we're finding the period based on a graph. The amplitude is given by the absolute value of a, this multiplier in front of our function, or you could also think of it as being the average of your max and min. So if we took the maximum value minus the minimum value and took that average, or that the distance between those, so 1/2 of that distance, then you would get your amplitude. Okay, so the midline is going to be the vertical shift. So in a parent function, the midline starts at 0, but it's going to be whatever this vertical shift is to your graph, which is capital D. And then your local minimum and maximum is just going to be the midline D minus the amplitude to find your minimum, and you take the midline and you add your amplitude to find the local maximum values for these. Okay, and this imaginary line right through, like here, the middle, that is your midline. Okay. Again, your amplitude is this value, I call it absolute value of A, and again, the phase shift is going to be found by taking your expression that's inside the function, which is b times the quantity x minus c. Set that equal to 0 and solve for x. And that gives you your phase shift or the horizontal shifting. And finally, the vertical shift, again, is just going to be your d value, just like it is in any other function. Okay, now the sine function and cosine function are actually the same graph, just translated, shifted left and right. So when you look at the cosine function, we can think of it in the same way. If we take these same values right here in the unit circle, and let's look at those in terms of the cosines. So now we're going to look to find our cosines here, which are still the angles, but now it's going to be the x coordinate. So at 0 radians, the cosine is 1. Pi over 2 radians, the cosine is 0. Pi radians, the cosine is -1. And 3 pi over 2 radians, the cosine is 0. Back to 2 pi, where the cosine is 1. So when we sketch the graph here, we have the same minimum and maximum of -1 and +1. Okay, but here, when we plot these points, we're still using the radian measures of 0 all the way to 2 pi. That's one complete cycle of the graph, or one period. Cut that in half, and cut each of those in half as well, and we get our 3 critical points. And so when we're plotting this, we take 0, 0 radians has a cosine of 1, so I'll plot that up here. The pi over 2 has a cosine of 0. Pi has a cosine of -1, so that drops down. 3 pi over 2 back to 0, and then finally 2 pi returns to the 1. So this right here is one full period of the cosine graph. Now it's going to oscillate as well and go back and forth as you continue on, but this portion is one period of that graph. Okay? It's the amount of time it completes within 2 pi. Okay, so to find the period, you do the same calculations. You're going to take 2 pi and divide by the b value, absolute value of your b. Once again, the b represents the number of cycles that that graph will pass through during a full 2 pi radians. The amplitude is the absolute value of your leading coefficient. The midline, which once again represents the line on which the graph oscillates, is given by your d value. It starts at y equals 0, but it's going to be a shift vertically with the graph. The local the local minimum and maximum are going to be based on taking your midline and subtracting the amplitude for the minimum, the midline plus the amplitude to get a maximum. And then finally, same thing with the phase shift or horizontal shift. You take the expression inside your function, set it equal to 0, and solve for x. And that's going to give you your direction of the horizontal shift. And then your vertical shift, once again, will just be your d value. So it's the exact same as what it was for the sines. All right, so let's take a look at how this is going to be used, or how we're going to be working with the sine and cosine graphs, which again, and when we find equations for graphs, I will show you that you can write the equation in terms of sine or in terms of cosine for any of those. Okay, so the first set of questions you'll be asked is just to get familiar with the graphing utilities. And what you see right here is the cosine graph starts at a maximum. Okay, so you can see right here, it starts at a maximum and goes to a minimum. So when you're using the cosine graphing utility or sketching a cosine, you go from maximum to minimum. The sine, on the other hand, starts at a midline and it goes to a maximum. So again, it's a slightly different set of 2 points that you'll use to sketch out your different trig functions. Okay. So here, when we're looking at the sine, we would choose the graphing utility for sine. And what we found was our sine starts at the midline at 0 radians, and then it goes to a maximum, and then it crosses the midline again, hits a minimum, and crosses the midline again. So this portion right here is our sine graph. Okay. And once again, though, when you are finding this graph, because you start with the midline and then you go to the maximum or minimum, what we can do is we would choose to plot these 2 points. So we'd plot our midline and our maximum, and then the graphing utility will fill in the rest of the graph. Okay. Now compare that to the cosine here. When we're trying to find the cosine function, a cosine starts at a maximum, then it crosses the midline, minimum, midline, maximum. So once again, this right here is the portion of the cosine graph that you would need to identify. Okay. However, when you use this graphing utility, once again, the graphing utility for cosine is going to be a max, and then a max, and then it's going to jump all the way to the minimum. So when we plot the points for this, we would start at a maximum, and then the second point we'd choose would be this minimum, and that's going to complete the cosine function when you're graphing it. Okay, so just make sure when you are working through these that if you have any questions on graphing that you contact me while you're in class. Okay, so the graphing utilities here are going to continue and fill in the rest of the graphs. But if you do notice, it asks you to determine whether these functions are even or odd. Remember, an even function is symmetric to the y-axis, and an odd function is symmetric to the origin. Okay, and what that would mean is it means that you can rotate your graph a full 180 degrees and it would map back onto itself. So when we look at this first graph, the sine graph, what you see is if you reflect it along this y-axis, it is not the same thing. So that means it's not an even function. Okay? But if you were to rotate this graph and look at the reversed image of that, if you rotate this 180 degrees, what you would see is that this graph will map right back onto itself. So this is an odd function. The cosine graph without any horizontal transformations, when you see it does reflect across this y-axis, so that's going to be an even function when you're identifying those. All right, so let's start to look at what we are going to be doing with using the function. Okay, so when we look at the function for this, let's first talk about what the b value represents. So once again, this is the number of cycles within an interval of 2 pi. Okay, and so when we're looking at this, the way that you can find your period is you're simply taking 2 pi divided by the absolute value of b. So that's the calculation we'll use for each of these. So here the period is 2 pi divided by our b value is the multiplier in front of our x. So pi over 6. Dividing by pi over 6 is like multiplying by the reciprocal, 6 over pi. The pi's cancel, we get 2 times 6, which is 12. So your answer for the first is a period of 12. Next, the period 2 pi divided by, again, absolute value of b. And here our b value is 11. So if we take that multiplier in front of our x and we divide, there's nothing to simplify here, so that is your period, 2 pi over 11. And then finally, this last problem, the period is equal to 2 pi divided by the multiplier in front of our x. So here it's an unwritten 1/3. Okay? We have the division of 3 has a multiplier of 1/3. So if we multiply by the reciprocal and calculate, we get 6 pi as our period. Now, eventually what we're going to be using the periods for here is to help determine the one cycle of this sine graph happens in one period. So if we were taking a function, and we're not going to use any other transformations, but if we took the function y equals the sine of pi over 6x, so without any vertical or horizontal transformations, what this means is that the graph is going to repeat every 12 units. Right? And so if we have a value of 0 here, we would mark 12. That's one period. And again, one period is going to be cut into 2. and then each of those are going to be cut into half as well. So the halfway distance from 0 to 6 is 3, here 9. So we have a maximum of 1 and a minimum of -1. Nothing changes there. And so what's going to happen is, because it's a sine graph, we go from, again on a sine, it is midline to maximum to midline to minimum to midline. And so that's the general rule for your 5 critical points. And so here, if we start midline, maximum, midline, minimum, midline. So this would be the sketch of our graph for this function. And that's how you use the period in finding the graph. If we jump down to this bottom one, once again, thinking in terms of how would you transfer this into a graph. So if we want to plot these critical points for just the sine of x over 3, again, no transformations, what we would do is we would say that this graph is going to complete one time in 6 pi units. So if we go from 0 to 6 pi, and then we cut that in half, 3 pi, and cut each of those in half as well. So half of 3 pi is 3 pi over 2. This would be 6 pi over 2, 9 pi over 2, 12 pi over 2. So if you think of them in terms of their fractional parts, you get your critical points. And once we have our critical points, again, our sine goes from midline to maximum to midline to minimum to midline. And so here is your one period of that graph. You can continue it as well. And that would be how we use the period in order to sketch graphs for sines. And we're going to do the same thing here with the cosine. Okay, so if we look at the period of a cosine is equal to 2 pi divided by the absolute value of b, where b is this multiplier in front of your x. So the first thing is, if we calculate these, 2 pi divide by our b value right here, pi over 2, or pi over 3, that's equivalent to multiplying by the reciprocal. The pi's cancel, so we get a period of 6. In the second example, your period is 2 pi divided by absolute value of b. Well, here the b value is 5. Nothing to simplify, that would be your period. And then finally, the period in this last problem is 2 pi divided by the multiplier in front, which is 1 over 7, which is equivalent to multiplying that by the reciprocal, giving you 14 pi for your period. And just like with the sine graph, each of these can be looked at in terms of, what if we just took this function of in terms of cosine of pi over 3 with no other transformations. We know that it's going to repeat in 6 units. So we have a max and mins that haven't been affected by any amplitude change. And for the value of 6, we know it's going to repeat from 0 to 6. And if we cut that in half and each of those in half, so 3 halves, 6 halves, 9 halves, we find the different critical points. And then when we're plotting this, our cosine function begins at a maximum. And then each critical point changes from midline to minimum to maximum, or to midline again, sorry. And then ends with the maximum again. So for a cosine function, we go maximum, midline, minimum, midline, maximum. So there's one period of the cosine graph, and it's just going to continue in each direction. Okay, same idea down here. If we are told that the period is 14 pi, that means that between 0 and 14 pi, this graph will repeat one time. The max and min don't change. And so if we cut this in half, we get 7 pi, and cut each of these in half, we get 7 pi over 2, 14 pi over 2, 21 pi over 2, and then 28 pi over 2, if we think in terms of the fractional forms. And so when we plot our points, we start with a maximum, midline, minimum, midline, maximum. So here is one period of our cosine, and that will just again continue. But that's how, once again, we will use the period of the sine and cosine functions when we're sketching the graphs. All right, so what if we're working with period, but we're given the graph themselves? Okay, so again, the period represents the amount of time to complete one cycle. where we're looking at it as an interval to complete one cycle. Okay, and so when you're looking at this one cycle, what you can do is remember that the sine goes from midline, right? So midline to maximum to midline to minimum back to midline. And the cosine goes from maximum to midline to minimum to midline and back to maximum. So depending on what you're looking at, if you start here on the midline, what we can do is we can look how long does it take for this to complete one rotation of this sine, or one cycle of this sine graph. Well, we see it goes from 0 all the way to 48, and so that is our period. Now, if we were thinking of this in terms of a maximum starting here, there would have been a shift that happened. Again, we could have thought of it as here too. So if we take this maximum and we want to go all the way to the next maximum right here, this would be the distance of our period, which goes from 12 to 60. That has a distance of 48 also. So you can think of it in either form, either as sines or as cosines. Again, this is looking at it as a cosine, and then this one is looking at it as a sine. Okay, so here in this next example, what you can see is for the first one, either one really works just fine. Here you can't really tell if you're looking at this midline here. It goes, your midline is this halfway between your two, or halfway between your max and min. So if you look at this, it's hard to tell what is this x coordinate right here. But you can tell here is a maximum going to another maximum. So I'm going to use the cosine for this, and I go from 0 all the way to 24, and so that would be my period based on the graph that I have. Right. You can also think of these here in terms of degrees and not just radians. And if you know that your period in terms of radians is 2 pi over the absolute value of b, then it should make sense that if we convert 2 pi into degrees, that's 2 pi is one full rotation, so that's equivalent to 360 degrees. So there would be the alternate form if you're finding the period in degrees. So calculation-wise, we take the period is 360 degrees divided by this multiplier 3. That's going to be 120 degrees. That would be our answer. And for the second example, the period is equal to 360 degrees divided by our multiplier here, 1 over 15, which we can work with by multiplying by the reciprocal. 360 times 15 will give you 5,400. And so that would be your period. Now, just like with the other, the graphing of this, if we were looking at what would here the cosine of just that multiplier in front, that b value, so 3x, without any other transformations, what we would see is that it would complete one full cycle between 0 and 120 degrees. So if we cut that in half at 60 and cut each of those in half, so 30, 60, 90, and what we would see is our graph is going to start with, since we're using cosine here, going to start at a maximum, midline, minimum, midline, maximum. So this is what our graph would look like, again, based just on that function. Even for the number below, same idea. If 5,400 is your period, that means that this graph, if I take cosine of just x over 15, with a period of 5,400, it goes from 0 to 5,400. The max and min aren't going to change. Okay, we can cut that in half, which is 2,700, and cut each of those in half. So half of 2,700 is 1,350. Then 2,700, then another 1,350 to that is 4,050. And then 5,400. So those are our 5 critical points. And so we can plot these points. A cosine goes from maximum, midline, minimum, midline, maximum. So this would be the sketch of your graph for that based on the equation here, having a period of 5,400.